First of all, I guess I should introduce myself. So I'm Gordon Cooper. I'm a product manager at Synopsys. If you're not aware of Synopsys, we make EDA tools. We have a large processor IP portfolio, and we have recently signed on for the RISC-V. So if we look at the semiconductor industry, it took 60 years to go from $0 to $500 billion. The expectation is it's only going to take 6 more years to double that. So 6 years ago, from 500 billion as an industry to 1 trillion. So where's all that growth coming from? Well, a lot of areas. Just look at a couple. If you look at automotive, clearly the amount of electronics in a car has exponentially grown. The estimate is by 2030, there's going to be 300 million lines of code in a car. If we look at AR, VR, that was sort of a niche area, and it's expected to be a $15 billion business. So a lot of areas for growth here. Obviously, artificial intelligence is helping drive the growth, but all of these require silicon. All of these are demanding silicon with extensible chips. And what really differentiates is the software. So we see this, I'm very focused in the AI space. It turns out more and more, the hardware is the easy part. It's the software that's the hard part. So we look at software really defining differentiation. What we're going to need for this continued growth is processors that are open source, that are easy to use, that improve time to market, and that's really where RISC-V comes in. If I'm honest, Synopsys, when we first heard about RISC-V, we were like, yeah, but we weren't that excited about it. We've been doing processors for 25 years. We have the ARC processor family. So when RISC-V was first announced, we thought, niche, maybe academic, momentum, traction. Our customers started to come to us and say, we love ARC, we love all the things you do, but can you give us the RISC-V version of it? Because we like the open source ISA. We like the extensibility of it. We like having controlling our own destiny and not being dependent on maybe one IP provider. So some of the pluses that they drove us to go and say, okay, can we marry the things we've been doing for 25 years with the RISC-V ISA? And as you see here, 40% growth year on year is a pretty impressive growth. So RISC-V is projected to continue to grow. In the IoT space, we're seeing up to 30% of the devices by 2028 should support RISC-V. We're seeing a tremendous amount of growth in the automotive space. But at the end of the day, it's our customers that drove us to say, okay, we're gonna embrace RISC-V. So why RISC-V? Why did our customers say they like RISC-V? Again, control of their own destiny. If you're doing an SoC and you've got 4 to 5 different processors and they all have a different ISA, that's a software nightmare. If your software team only has to program for one ISA, it makes your life a lot simpler. If you have an ISA that's extendable, you can make changes to it. That also gives you improved time to market and flexibility. And then there's the ecosystem. So we in ARC, we're really good at embedded solutions, but RISC-V really brings a broad and growing ecosystem. Now you should be careful, RISC-V is not a chip. RISC-V is an ISA. So it's a instruction set architecture. The implementation of that ISA is where some of the work is. Now, you can take the ISA and develop your own chip. That absolutely is what a lot of people are doing. We looked at it and said, here's all the things that we are good at from a Synopsys point of view. We're good at the implementation, we're good at the microarchitecture, the verification, the simulators, the development tools, etc. So what we liked about this is you take the RISC-V ISA in the ecosystem and combine it with all the things that we've been doing for 25 years, which is building out a licensable processor IP. So we announced back in November, we went from a naysayer to, okay, we're on board. We're on board with RISC-V, we're on board in a big way. We announced our ARC-V architecture. So ARC is our own sort of processor branding, if you will, been around for 25 years. We had our own ISA, but all we've done is taken all of that knowledge and combined it with a RISC-V ISA and called that family of processors for us ARC-V. If you've not heard of ARC before, it's kind of a well-kept secret. We're number 2 in terms of processor IP licensing. We have 3.5 plus billion units shipped annually. If you're like, well, why have I not heard more about it? It's because it really wins in deeply embedded applications where power, area, and performance are most important. We have an extensible architecture. So performance is everything. Where we didn't always win is because of the ecosystem. Let's be honest, there's another player out there with a big ecosystem, which is why we kind of like the idea of combining the two. I won't go into details on that, but let me just kind of jump to what we announced. So we looked at it and said, okay, there's a need for a player in this space with significant experience and from a big company. So we took our knowledge and we created 3 series. The RMX is 3 and 5 stage pipeline microcontrollers, if you will, with optional DSP variants. And the RH is the real-time series, and the RPX is 64-bit multi-core high-end processors. And what they all have in common is they're all based on they all use one set of software tools. So we have a Metaware tool chain, so we just apply that. And the other thing they all have in common is they will all have 2 versions. They'll have an automotive version and a non-automotive version. And why that's important is it's not like we do the non-automotive version first and then say, okay, let's put all the quality in the other one. We do it the other way around. Let's do the automotive and design for quality. So to do automotive, you actually as a company have to embrace a culture of safety and quality, ISO 9001. There's a lot of things that you have to do. So you kind of get that, even if you're not automotive, you kind of get that in the building of the processors, of the processor IP. So just kind of a reference here. Here's our existing family. It doesn't go away. We continue to support that. We have not shown here, but we have people still buying generations of products from 10 years ago. If you've written the software for it, again, this is why software is so important. If you've written the software for it, it's more effort to redesign the software than just to keep buying the technology. So the new family here at the top. And the other thing that we kind of bring from a processor point of view, we have a vector DSP and we have an NPU family. So if you look at AI, I've always find this interesting when people are like, oh, RISC-V, do you have AI? There is no AI standard yet for RISC-V. There's RVV extensions, and you can do a lot of AI there. So there's RISC-V and AI, where you can basically do the AI on like a DSP, or you can do what a lot of people are doing for high-end. You take the RISC-V and add a dedicated accelerator. So we have dedicated NPU accelerators that are custom made. So it's not necessarily for RISC-V, it's for any application that needs the performance. Okay, so from a before-late point of view. Now the nice thing about being at Synopsys, if you're familiar with our EDA tools with the IP, we also have a very large group that does other tools, and because we're Synopsys, we get to use those tools, and of course customers get to take advantage of those as well. So we have a Fusion Quick Start Kit that helps you when you're doing your design to get to faster time to market and better, in theory, better PPA than you could have done. We have a lot of tools related to simulating your performance ahead of time, either in software, which is here, or you can use an emulator. So testing your software before you have silicon, if you're developing an SoC, becomes really, really important. We have a lot of, particularly in the automotive space, where, hey, I know what I'm going to design. It's going to be 9 months or 12 months before I get my silicon back. I want to start my software team. How do I do that? You can use an FPGA platform, but as AI gets bigger and bigger, that becomes harder and harder because of the performance levels you need. So we have a ZeBu emulator. And all that being said, that's from the processor side, we have a large portfolio, kind of a one-stop shopping for IP in general. So we have interface IP, logic, memories, et cetera. Security is a big portfolio, Bluetooth, et cetera. So all these other pieces to play with. Okay, so I will leave you with our new slogan, or our new tagline, or our new, I forget what we call it now, our technology, your innovation. And the idea certainly is we can give you all the pieces to help you be successful in developing your SoC, your product. And here's a quote from one of our lead RISC-V licensees. But I guess I'll leave you from a Synopsys perspective. Why RISC-V? And I would say we're seeing the demand from customers. We're seeing the benefits of the common ISA, the open source, the extensible architecture, and really for our customers to say, hey, we want to control our own destiny. Why do we think it's a good thing? Our customers are driving us to do this, and we can combine 25 years of experience doing processor IP with an ISA and an ecosystem. We think it's a great match. So if you're interested, we have one of our directors of R&D doing a presentation on our NPUs, our AI, at 5 o'clock if you're part of the conference. And we have some booths, multiple booths around to come and check out. We also have the Synopsys booth here for RISC-V if you want to come by and ask questions. That's it. I'll take questions, but I thank you for the time.